This is Algebra 2 with trig, 1C.4b. We are completing the square for the second day. We're primarily going to talk about vertex form and taking standard form into vertex form. And then we're also going to talk about working with a circle. This is on the SAT. We're going to talk about working with a circle, putting this back into standard form so we know what the center and the radius. This is the whole reason we complete the square. Is this question that's on the SAT. All right. So vertex form that we learned about quadratics weeks ago is y equals a, x minus h squared plus k. To write a quadratic function in vertex form, we need to complete the square. You could theoretically find the line of symmetry, plug that back in, find the vertex, and fake your way to vertex form. You could do that. That's not completing the square, but that's getting an answer. But we want to do it using completing the square. So we're going to need to be sure that you isolate your y for your final answer. Okay, so there are different ways to plan this out. So what we have here, we have standard form of a quadratic. We want to write this in vertex form. We do not want to solve for x like yesterday. We want to write this in vertex form. We want a quantity squared. We don't have a quantity squared. We don't have a binomial being squared here. So what we're going to do, this is one way to plan it. We can subtract the 22 over with the y, so it looks a lot like we did yesterday. Then we take our b term, divided by 2 and square it, because that's going to help us determine how to turn this into a perfect square trinomial. So this is negative 10 divided by 2 and square it. Negative 5 squared is 25. So I'm going to add my 25 on the right side of the equal sign, and I can also add my 25 on the left hand side of the equal sign. Same thing we did yesterday. The reason why we put a 25 over here, we did some magic math to determine that, but the advantage of that is that this is now written as a binomial squared. This is factored. What multiplies to be 25 and adds to be 10? Negative 5 and negative 5 is going to make that work out. This side is y plus 3. If our goal is to write it in this format here, we're going to subtract 3 from both sides, and we have y equals x minus 5 squared minus 3. We're all done. We have our vertex. What is our vertex? It's positive 5, negative 3, from what we learned in the past. Now there is another way to organize this. Other teachers or other people helping you with your math perhaps could organize this a little bit differently. They take their y, they take their 95, and they just move it off to the side. They push it over. they don't push it over to the y, they just slide it over. They don't do the opposite sign over here, they just push it over. Now we do 18 divided by 2 and square it. 9 squared is 81. So I add 81 to this side, just like before. I already have my 95 here. If I don't put my 81 on the left side, because that's where y is, if I keep my balance on this side, what would I need to put on this side? If I put an 81 here, I also have to get rid of that 81. I got to balance it. It would have to be a negative 81. You can think about adding 81 to the other side and then subtracting it across. Maybe that makes sense to you. It's going to be the opposite. So these essentially cross each other out. But we don't want to cross them out because we need to write this portion, our perfect square trinomial, in factored form. And this becomes 14. And we're all done. You don't have to spend time bringing things back across. You can save a step or two by not moving things over to the y and then bringing things back after the y. You just push them over and you work with them over here. The vertex is negative 9, 14. Remember, it's always the opposite of what it looks like. The formula is x minus h. So it's x minus a negative 9 to make it look like x plus 9. That's why we're going to have the opposite of what's inside the parentheses, and then our plus k is our 14. So that's our vertex. And you can check your answer in your calculator. If this is a homework question, you could type in your x squared plus 18 plus 95. You could type in your x squared or x plus 9 quantity squared plus 14. You could type that into your calculator to look at your table, and you'll see that all the values are exactly the same in both columns. That means the two equations are equivalent. That means your work worked. Your two equations are the same. Okay, let's try this one. What do you see? What do you think we need to do here? For this next question, the issue is that the leading coefficient is a 5. We can't have that. I'm just going to push the 7 off to the side, kind of like we handled this method. I'm going to factor the 5 out of our values with the x's. Now we have a b term that has its a as 1. You have to have an a as 1 when you're completing the square. You have to have an a term of 1. So my b is 1, or my b is 2, divided by 2 is 1. 1 squared is 1. So I'm going to add my 1 to inside my parentheses. And what am I going to put next to the 7? If I add 1 inside the parentheses, what am I going to have to put next to the 7? So because we have a 1 here, that's 5 times 1. So we're going to have to subtract that amount to keep it balanced, to keep the equation the same. That would be just like adding 5 to the left-hand side and subtracting it back across. So this is 5 times x plus 1, because we factored that. This is a perfect square trinomial. We took effort to make it a perfect square trinomial. And this is plus 2. So my vertex is negative 1, comma 2. So we have vertex form, and we have our vertex. Now for the whole reason that we have learned about completing the square. It really comes down to this question right here. This is on the SAT. In the notes, this should not be a y. We already have y's in the equation. This should be an r squared. Radius squared equals x minus h squared plus y minus k squared. You learned this in geometry class. This is not a new formula for you. We want to get our equation to look like this. We want two perfect squares. A binomial squared for the x's and a binomial squared for the y's. So we're going to come over here and group our x's together. So I take my x squared and my negative 4x and I bring them together. I reorganize my y squared and my negative 6y. I bring those together. And I push my 8 over to the other side of the equal sign. From here, you should have an idea of what we're going to do. Any suggestion?
Going to factor both the x and the y's separately.
We're going to work with the x's separately. We're going to work with the y's separately. To do that, we're going to take the b term for the x's, which is negative 4 divided by 2 and square it, which is 4. So I'm going to add the 4 for the x's. I still have my y squared, my negative 6y, and I have to balance that. Since I'm on opposite sides of the equal sign, I'm going to do the exact same number. I'm not on the same side of the equal sign, so I don't have to do the opposite sign. Then I take my negative 6 divided by 2 and square it. And that gives me 9. So for the y's, I'm going to have a 9. So that is 13 minus that is 5. So my center is at 2, 3, and my radius. Remember, the value on the outside is r squared. So my radius is actually the square root of 5. To do our last one, it's the same exact thing, just an extra problem to practice. So I reorganize my x's together, I reorganize my y's together, I take my b divided by 2 and square it, which gives me 4. And I add that to the other side. I have my y values. 2 divided by 2 is 1 and square it. We put the 4 there so we could write it as a perfect square. We put the 1 there so we could write it as a perfect square. 4, 4, and 1 is 9. So I have my center at 2, negative 1. And I have my radius as the square root of 9. We only want the positive version because it's geometry and we're talking about the length. So that's a positive value of 3.